Hey everyone! Today we will be exploring Boolean logic and logic gates. So Boolean logic and logic gates not only power the software that we write in our code, but also the hardware that is used inside of our computer. So right off the bat, the first thing you need to know is that Boolean logic is something that will run if something is true. It could be something simple like an if true statement, or something even more complex that we're going to get to right now. The first type of logic gate that we will be exploring is called a NOT gate. So NOT gates look like this on a symbol, but when we explore it a bit more based on the actual transistors that are used in the circuit, they get a bit more complicated. A NOT gate simply takes something and results in the opposite of it. If we look at this NOT gate table, we can see that when something is true, it returns false, and when false, returns true. We can see a code example over here where if you're not finished your food, you will get yelled at. However, if you are finished your food, then you will not get yelled at. So since finished is false and not false is true, you will get yelled at. Now let's look at the actual circuit itself. Let's suppose if I turn my transistor on. So now electricity is flowing from here. So because there's already a there's a pre-existing current that is likely created when you plugged your switch into a wall, the electricity will not go to this path and instead will go into this other path. So this other path we can consider as ground, or just another path that's not allowing the machine to properly run. Now, however, if we were to turn this switch off, or this transistor off, the electricity can safely flow through this other path and thereby get the proper job done. The next thing we will be exploring is AND gates. AND gates are used when seeing if both things are true. For example, in this AND gate table, if both sides are true, only then we will get true. If we get both falses, we will return false, and if one's false and one's true, we will get false. An example of this could be is that your parents will pay you $10 if you clean your room and do your house chores. So in C++, for example, an AND gate, or an AND, is used by using two of the ampersand symbols, also known as the AND symbols. So this is how the symbol itself looks like in electrical circuits, but when exploring it a bit deeper, we can see this is how they look like. If I have one transistor on, or switch on, the electricity flows. But I need the other switch also on in order for the electricity to keep flowing. However, over here, if I have one of them on and one of them off, the electricity does not flow, thereby does not properly function. Now we will be exploring OR gates. OR gates check to see if one of the following statements are true. And if they are, it will then output true. So if both are true, we will get true. Both are false, we will get false. If one is true, then it will still output true. A practical example of this can be seen is that, let's suppose if your parents gave you the option of cleaning your room or doing your chores, and then you will have earned $10. So in C++, the OR symbol is with two straight dashes. This is how the symbol looks in its entirety, like on diagrams. So this is a circuit diagram seeing that electricity is flowing in two ways, even though it's from the same actual current itself. So if one side is true, the electricity will keep flowing and will go to whatever direction it's supposed to be going, even if one side is off. However, if both sides are off, then electricity won't flow at all. So that's how Boolean logic works. While it's a very simple thing, it's also a very complicated thing that is used to power all of our machines. Thank you guys for watching. Have a nice day.